Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3551 Distributed Computing. The unit is Consensus and Recovery. In this video, we are going to discuss about algorithm for asynchronous checkpointing and recovery. Junk Venkatesan algorithm for asynchronous checkpointing and recovery. The algorithm takes the following assumptions about the underlying system. The communication channels are reliable, deliver the messages in FIFO order, and have the infinite buffers. The message transmission delay is arbitrary but finite. Underlying the computation or application is event driven. The process PA is at state S, receives the message M, process the message, move to state S, and send messages out. So the triplet S, M, message then represents the state of the message. There are two types of log storage are maintained. First one is a volatile storage, then second one is a stable storage. Volatile log means short time to access but last if processor crash. Move to the stable log periodically. Stable log means this is for longer time to access but remain if crashed. Asynchronous checkpointing. After executing an event, the triplet is recorded without any synchronization with other processes. Then the local checkpoint consists of set of record. First are stored in volatile log, then move to the stable log. Recovery algorithm. The following notations and data structures are used by the algorithm. First one is the RZVD, that means received of checkpoint. Number of messages, that represents the number of messages received by process PA from processor PJ from the beginning of the computation till the checkpoint PK. Next, sent I to J, that means then second notation represents the number of messages sent by the processor PA to the processor PJ from the beginning of the computation till the checkpoint C. The basic idea of this algorithm is, since the algorithm is based on the asynchronous checkpointing, so the main issue in the recovery is to find the consistent set of checkpoint to which the system can be restored. The recovery algorithm achieves this by making each processor keep track of the both number of messages it has sent to other processes as well as the number of messages it has received from other processors. Whenever a processor roll back, it is necessary for all the processors to find out that if any messages has become the orphan messages. The orphan messages are discovered. Then these are discovered by comparing the number of messages sent and received from the neighboring processes. Then this is the procedure, that means the algorithm for when a processor restarts after a failure, it broadcasts a rollback message that it had failed. This is the first one, is the processor PA execute the following. The first step is the if processor PA recovering after a failure, then the particular checkpoint is set. Else then that latest event logged into the stable storage. If it is yes means then it is the particular checkpoint is allotted for the stable storage. Otherwise, the particular checkpoint is allotted to the PA. That means the volatile storage. And if then the next step is for k equal to 1 to n. The n is the number of processors in the system. Do the for each neighboring processor PJ do then compute the sent. Then send a rollback. Next end. Like this algorithm is executed. This is an example for consider the above example consisting of three processors. Suppose the processor Y fails and restarts. If event EY2 is the latest checkpoint event at Y, then Y will restart from the state corresponding to the EY2. Because that means from this figure, because of the broadcast nature of the rollback messages, the recovery algorithm is initiated at the processor X and Z. Initially, X, Y, and Z set the checkpoint to likewise, that is respectively, and XYZ send the following messages during the first iteration. Y sends the rollback of y comma 2 to X, and rollback of y comma 1 to Z. Likewise, X send the rollback of x comma 2 to y and rollback of x comma 0 to Z. Z sends the rollback of z comma 0 to x and rollback of z comma 1 to y. Thus, this algorithm is worked in this way. Since the residue of message is x will set the checkpoint to x point, satisfying the both conditions.